Alright guys, sorry about that. So now we're going to try to solve some equations here. So let's say, for example, we have a 2, so the point, 2 liter uh, sample. Sorry about the pad for handwriting. This is kind of weird on the computer. We got a 2 liter sample of air collected at 298 Kelvin. So 2 liter sample, 298 Kelvin, we collected it. And then this 298 Kelvin sample was cooled down to 278 Kelvin. So now, as the previous laws tell us, this volume is obviously going to decrease. So this is going to be a decreasing situation instead of an increasing situation. So now we're going to try to calculate the volume of air at this 278. So let's take it first and realize our equation. So we have the different we have Charles' law in the form of V1 to T1, so volume 1 to divide by temperature 1, and then equals volume 2, sorry there, divided by temperature 2. So we're going to lay that out like a regular math equation with over each other. So we're going to do V1 over T1 equals V2 over T2. So there we go. We got all laid out. And in this equation, we're going to want to cancel out the T2 so that we can solve for V2. So let's multiply this by T2. We get T2 out of the equation there on the right side. So equals V2. So we're going to have V2 equals T2 times V1 over T1. We're still going to keep that T1 because it's not T2. We want to still keep the quantity of T1 equals that 278 Kelvin times the 2-liter sample over 298 Kelvin, which is the original heat at which we collected the sample. And if we are solving all this, we get rid of the Kelvin there. Get rid of that. We solve it through. So I'm going to have you guys try to solve this part right here on your calculators if you're watching this. And then, as you find out, you are going to get a volume of 1.9 liters. So that shrunk, obviously, by only by 0.1 liters. So it's not a big shrink, but we can see that because the temperature decreased, the volume also decreased. So, all right. So thanks for watching. I hope this section was able to teach you about Charles' law and the differences between temperature, absolute zero, and all that, and how to basically solve for equations asking what happened to volume inside certain temperature and gas related equations. So thank you, and I hope you enjoyed the video.